Okay. Exponent rules. We're going to start with the zero exponent rule.
Hey, what's up, record? What's funny? Exactly.
Not your joke.
Okay. Anyway, hi, Mr. Bennett.
Hello. Okay, now we'll get started, and I'll just cut all that crap out. Zero exponent rules. Okay. Anytime you have a base number, so if we're looking at x to the 0 power, what is the base number? X. Okay. Anytime you have a base number set equal to a 0 exponent, the rule is it equals 1. Okay. 12 to the 0 power. 1. 5x to the 0 power.
No, wait. Five.
Sophia, why do you think it's 5?
Because, okay, so you know when...
Let me give you some confidence. You're right. So work through it.
Okay, I don't know how much number. I thought 5 times x, and I know that x is 1. So
That's exactly right. There you go. Okay, so you have 5x to the 0 power. That to the 0 power is not for both of those individual values. Okay, the 0 power, because we don't have parentheses, is just to what it's attached to, which is the x, right? So x to the 0 power is 1 times 5 is going to be a 5, okay? So let's look at the next one. Negative 2 to the 3rd power times n to the 0 power. Almost. You went one too many with the 2's. Yeah, there you go. Negative 8. Okay? Negative 8. So we have n to the 0 power. That's just 1. We have negative 2 to the 3rd power, and that is negative 8. Okay? Let's move on to the negative exponents. So with negative exponents, we have a base number x set to a negative powered exponent, so negative a. Okay? What that is going to translate to is the reciprocal. Okay? And I'll show you what that looks like. Reciprocal is you're just basically putting it over 1 or under 1. Okay? So you're changing it into a fraction. So it's going to be x to the a power. Notice what else I changed. What else did I change? The negative sign is gone. Okay? So you have a negative exponent. Okay? You're going to move that whole term to the bottom, change the exponent to a positive. Now it's 1 over x to the a power. Okay? Some examples of that. We've got 3 to the negative 2nd power. So it's going to be 1 over 3 to the 2nd, which is what? 1 over 9. Okay, a to the negative 7. It's going to be 1 over a, maybe, a to the 7th. Okay, and then we've got p to the 4th, q to the negative 1st. See if you can figure out what that one would look like. We would end up having p to the 4th over q. Okay, so you've got p to the 4th. That one would stay on top because it's a positive exponent. And then you have q to the negative 1st. So you move q down. It's q to the 1st, which is just q. So there you are right there. Sorry, my q doesn't look like an English letter. It's better, but not great.
It's not any better.
That's a q. This is a g. This is a q.
What is wrong?
there like a little dash.
It's the cursive in me. I can't help it, guys. Okay.
Stop writing in person.
Let us keep.
Let me keep.
Sorry. Nobody can read that.
You just did.
I didn't actually. Somebody gave up.
So what's the cue supposed to look like?
Just a circle and a string down.
Just-
Yeah,
Oh,
exactly.
use symbol.
That's a 9.
No.
No.
You have to give it
You
a
have to
little.
give it like a tail, like a tail. No.
I'm confused.
Give me the thing. Give me the thing.
Wait. Let me show you.
No.
Kind of.
That's an 8.
No, look, you gotta give it like a little, like a.
Mr. B, you're gonna have to restart your
No,
recording.
quit putting it to the
Why
side.
does it look like Ava's 8?
Look.
That's not.
Your recording is gonna be us saying no for a long time.
That's weird looking.
You're weird looking. Oh. Y'all heard me? I just roasted Mr. Bennett.
And then you're not getting the award next quarter.
I didn't
You
get
can't
the
go off favorites.
So
That's
you're
not fair.
not gonna get it now.
You can't go off favorites. That's not fair.
So are you
That-
gonna win the
What do you mean I
award?
can't go off favorites?
Yes, it is.
Did you get a win
Oh,
award today?
I'm not gonna win.
Okay, let's come back.
Hey, did you get one today?
Let's come back.
Did you get one
Let's
today?
come. Levi, sit down. Sit down. We understand. Children. Yes, because it sounds like that. Do what? No. Because no, I'm not gonna. So, first of all, it's not unfair for me to pick my favorites. That's literally what. Well, it's one of my jobs. Well, no, I'm not trying to offend you, Levi. I'm just saying, why would it be unfair for a teacher to pick their favorites?
Because like they can fail your class, but you get the reward for doing nothing.
No, for sure. Like that would be inappropriate. I would agree with you. Okay, but I don't think just in general it's inappropriate for a teacher to just pick their favorite students because they're their favorite students for a reason. You know what I mean? Okay. It's a secret.
I think it might be red.
Ren believes it's her.
Wait,
Yes.
who did you pick for? Oh, it's Angel.
That is exactly what his name is. Sophia, what's up?
Okay, so for the second one, I'm finding my term.
Yeah.
The 2k to the power of 3 is negative, right?
I think so. So ask your question one more time. Sorry.
So is the 2k to the power of 3 negative?
Are we looking right here?
Yeah.
This one right here, is that what you're talking about? Yes, it is. Okay, sorry. Brain fog. Okay, 10x plus 3x. Okay, in that middle section would be what? 10x plus 3x. 13x. Okay, we can combine them because they are like terms. They have the same variable, same exponent. Okay, 7k minus 2k squared plus 6k squared. So this one, I'm showing it to you because they are slightly different. Even though these both have k's, you cannot combine them because now we are not just looking at do the variables match, but the exponents need to match if you're going to add or subtract them. Okay? Because when you're adding or subtracting numbers that have exponents, the exponents don't change at all. Okay? So we just have 7k because we don't have another k to combine it with. Then we have negative 2k squared plus 6k squared, which is going to be 4k squared. Okay, then we have negative 5m squared. So sorry. I know. Negative 5m squared in minus 4m squared in. Can we combine those? Do they have the exact same variables and exponents? Yes, they do. So you can combine them. Sophia? They're being multiplied together. It looks like there's some space in between them, but it's just because of the exponent. Okay. So we have negative 5 minus 4. which we would all agree is -9, or according to y'all, a negative q, m squared n. Okay? Product rule. Product rule. When we think product, we think multiplication. Evan's going for that Q3 award. Okay, so we have x to the a times x to the b. What's that going to be? Bases are the same, so the bases stay the same. So we have x. Now, on product rule, this is kind of counterintuitive to what you think. Okay, when we are multiplying numbers that have exponents, you add the exponents together. Hello, Miss Clark. Of course. Okay, so try and fill in those examples at the bottom.
I'm making bank. Bro, I was watching the Super Stop What did they just There's 7th graders, they got it. That's the problem. So do you keep the days or do you multiply them? Do you keep the days or do you multiply them?
That is a great question. Keep the base the same. The base is matched. Right? And then you just add the
What do you mean?
Okay. Well, let's go. What's up?
Walked out.
I'm so sorry. To be fair, I didn't hear you. I was ignoring you. So what's up?
Leadership ethics, I mean, yeah.
Okay. Which is what's that? So you have headed and do it. So you have 7.
I'm better than you. You know what this door said about
Yeah. So 6.
I love you.
So 8 is the same.
They're all the same.
And then 3 minus 5. So you can do that one right there. But the way that you're doing it is wrong.
I don't know what I'm doing.
This is what I do.
No way.
Okay, sorry guys. Mary Beth, you didn't take over? You didn't take over? I said, Mary Beth, you got this. You're supposed to keep going.
I didn't hear you. I was focused on
Come on,
my
Mary
history
Beth.
working.
Very best, we gotta be ready. We gotta be ready. Come on, come on. We gotta be ready.
Oh, wait.
Oh, we didn't get that.
Yo.
Come on.
Oh yeah, because there's the negative on the board.
Okay. Oh, all right.
Okay, now, this is where it can get a little confusing, okay? But if you have the same base, keep the base the same, okay? On this last example, are our base numbers the same? As far as our coefficients go? No, okay? So when you have a coefficient with a variable, think about what the exponent's attached to, okay? Is the exponent attached to the -2 or attached to the 9? That is not a rhetorical question. You're allowed to answer it.
I don't know what you just said.
Does -2 down here have an exponent?
Yeah.
No, it doesn't.
No.
Right? It doesn't. Okay? Does 9 down here have an exponent?
No.
No, it doesn't. Okay? So you can multiply those together. Okay? Now, if I'm giving you a problem, for instance, okay, and this is the correct answer, come on, this is driving me crazy today.
I don't think it's working.
Okay. If I was asking you to give me an answer in exponential form, 9 to the 12th power would be an example of that. Okay. If I was asking you to simplify that, then I would let you get your calculator out and you just type in 9 to the 12th power, and it'd be some number in the, like 10 to 100 millions or something. Okay. So keep that in mind. We have x to the 3rd times x to the 4th. So it's going to be x to the 7th. Okay. And then we have y to the 8th. -18, x to the 7th, y to the 8th. Okay. What's up? Perfect. Quotient rule. We have x to the a power over x to the b power. What do we do with exponents that we are dividing? So let's think about this. Yeah, math makes sense. Okay, I know it can be complicated, but at the end of the day, math is pretty directed towards some common sense. If you add exponents when you're multiplying, what do you do with exponents when you're dividing? Subtract. Okay, so you have the base is the same, a minus b. Yes. These two right here. We have x to the 3rd times x to the 4th. We're going to combine those, keep the x's the same, add the exponents. So 3 plus 4. Okay? And then we do the same thing with the y's. So we have 7 y to the 7th on this one. We have y to the, it's not there, so we know it's y to the 1st. Okay?
Your 8 looks like a 9.
Do what?
Your 8 looks like a 9.
My 8 looks like a 9 or my A?
Your A.
I would agree with that. Nope. I'm 32. This is just the way it's going to look.
So you need a fix for your one line like Rowan?
Yes. Do what? When is she having another baby? Let's talk about this off the recording. Okay, so x equals, or not x equals, x to the a, stay with me guys. X to the a over x to the b equals x to the difference of a and b, right? Okay, so if we have this x down here with a b, I'm talking theory now for a second. So you can either look at your paper or look up here, just make sure you're following along, okay? If you have this x to the b power on the bottom right here, how could you move that up to the top? So if I have x to the b power, and all I told you was I gave you the problem x to the, oh my God. There we go. X to the a over x to the b. Rewrite this with the x to the b up on top. How would you do it? So let me ask you another question. If you have x to the negative a up on top and x to the b on bottom, how would you move the x to the negative a down? You just put a 1 up on top and you change the sign to move that down, right? It works the other way. Okay, so if I said rewrite this, you can move this up here and it would just be x to the a times x to the negative b. Okay, now we're using product rule. What do? Like these are being multiplied now, right? I'm not talking about on the worksheet. Okay, I'm just talking theory. If y'all would just listen and have a conversation with me, it would help instead of trying to figure out where I'm at. I'm just pulling this stuff out of my brain. Okay, so x to the a power times x to the negative b. Product rule says we do what with the exponents? Yeah, we add them. Okay, so you would just do a minus b, right? The product rule or the quotient rule just works the same way, okay, in a different order. We now have a minus b. Is that b negative right there?
Yeah.
On this part right here? Yes, it is, okay, which means we could move it back down to the bottom and we'd have x to the b power, okay? I just want to show you how they kind of work together, but I'm confusing more people than I would care to, so we'll move on. Let's do did we do those examples yet? Okay, we should go ahead and do them. So we've got negative 2 to the 20th power over negative 2 to the 5th. That's going to be what? How do we write it? This first example right here. Negative 2. Okay, so let me ask you a question. If I write it like this, is that correct? Around what? There you go, around the negative 2. Okay? If you want to take the exponent of the whole thing, you have to use the parentheses around the whole thing. Okay? If you punched this, into a calculator, the calculator would do 2 to the 15th power and then multiply it by a negative. You don't want that. Okay? You want negative 2 to the 15th power, so you got to use the parentheses. Okay, fill out the rest of those examples real quick. I'll give you about 30 seconds. What's up, man? Uh-huh. Okay. Which one do we want to look at first? That last one? We can do that. 28m to the 5th over 4m to the 3rd. Okay, so we said numbers that are the base, okay, or integers that are the base, we can leave them the same. But if they're coefficients, we need to go ahead and do the math. So what's 28 divided by 4? 7. Then we have m to the 5th divided by m to the 3rd.
Teachers and students, please pardon this interruption. I have an announcement for the basketball game tonight. Girls basketball, your game has been canceled for tonight. Please make arrangements to get home today. Boys, your game has been moved up to 6 o'clock. So the only game this afternoon or this evening is the boys' game. It is at 6 o'clock. Please make sure that you have a ride home by 7 o'clock. Thank you.
Go team. Okay, so we have m to the 5th over m to the 3rd. What do you do with the exponents? So it should be m to the 2nd. Okay, I'll go up and look at the x. We have x to the 12th power over x to the 3rd. What's up?
So on the first one, why did you divide the -2?
That's a good question. So there's no variable. That's really the simplest answer. Okay. Coefficients, you go ahead and do the division on them. Okay. But if it is the base number, which means it has the exponent attached to it, they stay the same. The difference between this 2 and this 28 and 4 is that the exponents right here, Sophia, are not part of the number. Okay. The number is a coefficient back before the variable. But this -2 up here is the thing that has the exponent. Okay? Does that make sense? Okay. X to the 12th over x to the 3rd should be 12 minus 3, x to the 9th power. We have r squared over r squared, r squared s squared over r squared s to the 3rd. You're on the right track, Ivan. You got close. Not 0, but I like where your head's at. Think back to what the 0 rule said. There you go. So R2 over R2 is just a 1. Okay. Now, who among us used the exponent rule to do that one? You had r squared over r squared. You moved it up, knew it was 2 minus 2, so it came out to 0. Then it was r to the 0 power, which is 1. Okay, that's okay if you did. That's great that you did. Okay, you could also just look at it as a division problem that we're used to working with. So if you have 2 over 2, what does that equal? 1. If you have x over x, what does that equal? 1. If you have 10 over 10, what does that equal? 1. So if you have r squared over r squared, what does that equal? 1. Okay. Now, the quotient rule for exponents shows you why that works. Because if we move this up, it's going to be 2 minus 2. That comes out to r to the 0 power, which is 1. Okay. They are both 1, and we get there in different ways with different rules. Okay. So r squared over r squared is just 1. What's s squared over s to the 3rd? S to the -1. So your answer should be 1 over s. Okay. And first period also, after I gave this answer, I saw a lot of people going down and changing their answers. Make sure that you know why what you wrote is different. Okay. If you're not sure why it's different, please make a note so that you can ask me. Power rule. Almost done with this page. We have x to the a power, and then all of that to the b power. Okay, so now when we are raising, raising a power to another power, this will be the one time that you actually, I would like your opinion. What do you think is going to happen? It's a fair assessment. What else? What do we think this is going to look like right here? X to the what? X to the what? X to the A times B. Okay, so what you're looking at is now you're looking at this exponent right here like it needs to be distributed. Okay, and it's going to be distributed to each individual value in a term. Okay, so for this instance, it's going to be distributed to the x to the a, and you're just going to multiply those exponents together. Okay, so let's look at these examples down here. We have 7 to the second power, all to the 9th power. What's that going to look like? 7 to the 18th. Okay, we have w to the 4th power, all to the 3rd power. It's going to be w to the 12th. Okay, this last one is the example of what I was talking about as far as distributing. It's got to go to each one. You're going to take this 2, and you're going to square the negative 4 first. So it's going to be 16. You're going to take the 2 to the r to the 3rd. So it's going to be r to the what? 6th. And then you're going to take the 2 to the s to the 7th. It's going to be s to the 14th. Any questions over that? Nice. Let's go to the notes. Yeah, your next page. It's not usually, actually. Levi, were you really asking? Yeah. Well, if so, when you ask, you got to look at me so that I know you're talking to me. Does that make sense? Okay. Yes, you can go. Okay. This is A3. This is the 31st. This is pre-algebra. We are working on monomials. Yes, monomials. It is like a polynomial, but it's only. Y'all are about to really get into polynomials. Yes. Exactly. This is the first step in that. Okay, so a monomial. Okay, you've worked with monomials before a lot. Okay, you just maybe have not ever referred to them as such. Okay, a monomial is a number, a variable, or a number and a variable. Some examples. 2. X. 2x. Negative 1/2. 3x squared y to the 4th. All of those are monomials. Okay? Monomials with the same variables and exponents are like terms. Okay, all that's saying is if I have 3x to the 2nd, y to the 6th, and then I want to subtract 5, the variables and the exponents must be the exact same for that to work. Yes? What is not a monomial? Binomial, trinomial, multiple polynomials. Sure. X squared plus 6x minus 8. This is a polynomial because it has multiple variations of. It's got 3 separate terms. Okay, it has exponent, it has a coefficient with a variable, and it has a constant. We'll get into it more. Yeah. Okay. Adding and subtracting monomials. To add or subtract monomials, you must. It's our favorite phrase in here. Combine like terms.
Not in the class.
Uh-huh. Do not change the variables and exponents. Let's look at number 1. 4x plus 5x equals 9x. Negative 12ab minus 2ab equals negative 14ab. Notice that the variables stay the same. Please try number 4, number 8, number 11, and 14. Right there, Levi. Further. Yeah, there you go. We'll just look at Evans. That'll help. Okay, 4, 8, 11, 14. That's why it's being weird. It was still working, actually. Sorry. It's because there's a bubble. Okay. Is that you that did that the first time? You shouldn't have told me about it the first time. Yeah, you shouldn't have told me. I don't know how long it would have taken me to find out.
Yeah, and then you said you realized.
It's true. Okay, number 4 is what? What do you think it is? I'll leave everybody a little bit more time.
Probably not done. It's negative 8 though. It's 0.
Okay, number 4. What do we think it is? What do we think it is? 0.
I know.
Number 8. 10 x to the 5th y squared minus 14x to the 5th y squared is. I will wait another 60 seconds. While y'all are doing that, I'm going to check my my grades. Ava, you good? I know the nurse does hearing tests. If you need it.
I heard
microwave.
Microwave?
What did you say?
My grade.
Your grade?
Oh, great. Well, AIDS.
Grades.
What?
First of all, I'm not going to check my aides at school. Okay. And then second of all, I said grades.
Okay.
Do what? What?
I think they give hearing tests at the nurse's office.
You're in
I don't think that's true.
Well, if you're playing soccer, how are you really gonna like?
Actually, Mary Beth, that's actually would be illegal to not let a student play because they couldn't hear.
No, but on the rate one thing, that's what one of the things is.
I need to see. Oh, we scrolled down a little bit.
Sorry, remember it's a pinata. There's candy inside.
Why have you not opened it?
Because I just got it today.
Well, you should.
Go put it back.
You should brush.
Okay, here's number 8. We have. We do have homework. Okay, so let's get through this. Okay, we have 10 x to the 5th y to the 2nd minus 14 x to the 5th y to the 2nd. That's just 10 minus 14 is -4. Exponents and variables need to stay the same. Okay. Number 11. We have our k squareds. So we can put those together. So what's 7k squared plus 12k squared?
It's
19k squared. We have -k plus 4k. Yes, plus 3k. Sophia. Say that one more time.
So like the title of this page is adding and subtracting monomials.
Mm-hmm.
So wouldn't these be like polynomials, binomials, and like that? It's adding and subtracting. So you're adding and subtracting right.
So we are creating. So maybe I wasn't clear enough. We are working with monomials, but we are technically we created right here a polynomial. Yes. Okay. But a monomial is specifically just one component of that. Yes. That's a good question, Sophia. Okay. 14.
Wait, I have a question
Oh.
regarding
Regarding monomials. Okay, go ahead.
Okay, so each vowel gets its own syllable, right? And there's 2 vowels in the
Is
last
this a
one.
math question?
Yeah.
It's about how many vowels, how many syllables.
But you're saying 3 syllables, but there's 4.
Monomials.
Yeah, but it's an IA, which is IELTS.
Okay, so what your complaint is that you actually just need to take it up with the English language. I can't help it.
Well, unfortunately, Miss Dobbins is not.
Is Miss Dobbins the spokesperson for the English language?
No,
Easy. Be nice.
Now she gets it off the YouTube.
That's awesome here.
So what's well, how should I say it?
They're like monomials or something.
Monomials. Okay. We are working with monomials. Monomials. Monomials.
May I use this real quick?
Your phone?
Yeah.
Sure. Okay, let's look at 14. We need to get through this. Y'all are going to have a lot of homework. Okay, a squared b squared. To the a squared b squares, that would be 4a squared b squared. Sorry, this thing just keeps randomly not writing. Okay, there we go. And then we have 9ab minus 12ab should be -3ab. What's up? Monomials. Yeah. Monomials.
That's 4 syllables. You're saying monomials.
Okay, so I'm from Texas, and I don't know who Siri, where her origin, region is.
She's from the United States. American voice.
American doesn't help. I'm from Texas. I'm from Texas, where we say monomial.
You also say y'all. That's wrong.
You also say
Yeah.
Amarillo.
You just said y'all. You literally just said y'all. Also say y'all.
I say y'all.
Amarillo is about.
Did you know that Mr. Bennett?
Yeah.
Mr. Bennett.
That's how much accent you use there.
No, I think Oklahomans talk very similarly to Texans. I'm gonna say do what? Well, because I'm not from Oklahoma, so. Let me finish the notes, and then we can keep debating how I'm bad at talking and writing. Okay. So. Okay. So. Do you want me to?
No.
It's fine.
I was leaving them up here on purpose.
No, can you like erase them so you can actually try to do them?
You're gonna.
Why you say that?
How you gonna learn?
You know what? Levi's right.
He lost that third quarter.
Yeah.
That's right. Okay. I'm leaving the other ones up there. Please try them. Okay. Y'all are all copying down the answers. They're up here. My suggestion is to try them first. Okay. So now we're using the product rule. Okay, with the however you say it. Monomials. Monominals. Monominals.
Say like import or something.
That's gonna sound a lot worse on the recording there, Ava. Okay. Yeah, it's great. It's great. Okay. X to the A times X to the B means X to the A plus B. So I want y'all to work 20, 22, 23, 26, and 27. Okay, all the ones that I boxed. Yeah. Sounds good. I think everything is funny.
Yes. When it's not supposed to sound bad, but they make it sound bad.
Gotcha. Hmm?
Yeah.
No, not today.
So what did you say about the polynomial?
About it.
Where are we doing?
Well, yeah, we'll be doing quadratics, which is
That's triangles.
quadratics.
No, that's squares, right?
I mean, a square is a square.
That's a quadrilateral.
Quadratics and quadrilaterals are different.
What's quadratic? Is that,
Quadratics is
oh my gosh, we're doing that stuff?
parabolas. Parabolas.
It's up there. Quadratic formula.
Oh, yeah. There you go.
That's what we're doing.
Yeah, x is equal to negative b plus or minus the squared root of b squared all. Yeah, you'll learn the song. We're gonna go around to all the classes and sing it. Yeah, and I'm gonna let the mass singers and all of Miss be up front.
Wait, why do we have to learn 8 times?
Because you'll need to know it. It's something you don't get you don't get that on a formula chart like for a state test or like SATs and stuff, but you need to know it.
So can you name 3 things that you use in your everyday?
Yes.
What's the question for 27? Because it's like, that's not on the page.
X to the 4th times y. X to the 4th times y times x to the negative 1st.
What are the 3 things you use in your everyday life? This is a completely
So are you math related? I guess is what you're saying.
That's like 3 things you use in your everyday life.
Okay. My phone. A bunch of stuff.
But I need 3.
My toothbrush. Soap.
See, notice how you didn't say
Okay. I was wondering where you're getting.
Yeah,
That's true.
quadratic formula.
Okay, here's 20, 22, 23, 26, 27.
You know how it is these days.
Wouldn't it be 1 over? What? What? What?
Mr. B, you're messing me up.
How am I messing you up?
It's like you're erasing.
What are you
I'm
doing?
thinking I'm wrong, but I had it.
What?
Well, I didn't have that. Actually, never mind.
What is that?
So you have -1 to the negative second power times -1 to the negative 3. So it's -2 minus 3, which is -5. Because it's 1 to the -5, you got to move it down to the bottom, which makes it -1 to the 5th. Okay, -1 to the 5th is a -1. Okay, hold on. Yep, Bella. Do what? It's a great question. What is this? Pre-Algebra? You'll use it next year in Algebra 1.
Actually, like in real life.
As far as exponents go, if you enter any sort of field that is STEM related, science, tech, engineering, mathematics, you'll use this all the time.
So you're
I mean, then you won't. I don't know what to tell you.
So, Mr. Bennett, what you're saying is if I'm certain how to be like cut into people, like, hey,
No, but what you will end up doing, as far as a surgeon goes, is you will learn the
I mean, I don't think we're gonna use like exponents or like dosages and like medicine.
So you won't use exponents for the most part, but you will use a lot of like measurement style math for sure. Okay, 23. We've got x to the 7th. We have 4a to the -5th, which is going to be 1 over a to the 5th. And then we have x to the 3rd y. Just number 26. You have a to the 1st times a to the 3rd times a to the -9th. So I'm just using product rule. So you've got 1 plus 3 is 4, minus 9 is -5. And so the a then moves to the bottom as a to the 5th. I am not making them. They are made by the problem. I'm just writing the answer down. I did not create this.
No, we ate that. Or we take it.
Okay. Here is my compromise to you. Because this took so long, I will wait and give you your homework the next class, and we will just make next class your catch-up day.
Okay.
So that first period can catch up to y'all. Yeah. Yeah. Up here? Okay. So what we have then at the bottom, okay, you need to do 29, 32, 33, 36, and 38. Yeah.
Why are the papers always like this?
Because the printer is sucky.
Can we fix it?
Okay, what did I say? 29, 32, 33, 36, and 38? Okay. Do those real quick. Those will be your last ones for the day. I'm excited to see all of the individuals that ran cross country in the fall at track practice today. Uh-huh. Yeah, I mean, go to your game. You what?
Why would it cost 70 at Polk Middle School?
We're the 7th grade B team boys. Why was?
But why are those people B team?
Because they didn't make the A team. So we had a bunch of kids.
So that's like varsity in JV.
We had a lot of students. So we had a seventh grade A and B, 8th grade A and B, boys and girls.
Can I like inspect them? I need to see what Polk Middle School.
The one beside it is the A team. Okay, I'll give you another 4 minutes. You what? I don't have a set day right now. Right now, I'm just trying to pick the best weather day that we have. To do it? Only if you are you want to do it, Ian?
What are you looking at? Have a piece of gum. Have a piece of gum.
You're young.
That's the way I speak. Nobody says
It's also may I have.
Shut up!
I don't care.
No, it's snowing.
It's a joke. You were supposed to laugh.
Oh, I haven't laughed like that in a long time. Good one.
Yeah, good one. Good one, Bella. That's the skin of the killer, Bella.
You talking about me?
Yeah, it's a Twilight reference. We were talking about skin, and that's Bella.
I'm more red tinted than diamond tinted though.
Oh, I understand. Bella!
So it's okay. It's okay. Okay. You here, actually, you know what? Let me